Hello, everyone. Hello, everyone. Today I'm going to share with you the kind of from Unity's sample GitHub scene, and I will share with you what's the kind of AI model inside. Okay, so yeah, so thank you so much for joining us today, and I will share with you how, if you want to support us, subscribe our Patreon to get live access. Okay, subscribe our Patreon to get access to our source code and also our all the links that mentioned in the event. And also you got the chance, if you subscribe the highest perk, you will get the chance to access to the live streaming and be in the Zoom as the instructors. Okay, so let me start to share with you today's code. Give me a sec. Hello. Yeah, so this is my second computer. So today I'm going to share with you is the kind of like it's a board game AI sample. So this game is called Othello mini game. This was from like this Unity developer get an AI model from this Stanford kind of PhD student work, if you see his work. So he create a kind of a training AlphaZero types of Go, AlphaZero kind of Go game. If you don't know AlphaZero game, you can kind of go online and search. It's pretty much was the chase game that, yeah, AlphaGo Zero, you can search this one. And it was more like using AI model to train how AI how to play a chess game. Okay, so yeah, for those who don't know this, what I learned is that this Stanford PhD student trained this model. And if you want to take a look, I'm still learning Python, PyTorch, and TensorFlow. So if you kind of like want to learn more, you can jump into the link. You can study more. Pretty much, he was using the AI model and start training the probabilities of 8x8. I remember 8x8 types of kind of like a chessboard, and allows players to have different easy, medium, and difficult mode for them to kind of see the probability of winning. For example, random and greedy. Random, he categorized the player into two different types. One is random. Random means that the player randomly pick a spot on the chessboard. Greedy one is that the player is a little bit greedy, wants the maximum kind of like the chase kind of component to be, or the opponent chase like a little dot to be believed, the maximize. So for those two types of player, the winning chance of the AI. So for example, you can see if the player wants to maximize the flipping dots, then chances at the beginning, AI will win probably about 0.5, probably tie. But when time goes by, pretty much AI will get better and better to win the game. And at the end, pretty much one means that AI will likely to win the game for both of players. So yeah, so you can jump into and see his paper. Yeah, so I want to share with you his paper. So you can get in and take a look of his paper. So yeah, so yeah, I will also share. Yeah, so pretty much use the math and trying to figure it out how to win. If you can see this random and greedy, and also like different probabilities, 6x6 board or 8x8 board. Okay, so you can see like how this game works. Later on, I will kind of walk you through how it works. And today pretty much is also walk through the entire code. And if you want to find the code, you can go to, I think it's here, Sentis sample. The entire tutorial was not even being list on Unity's side. So you need to kind of dive into Unity and get the link. So if you get in, you can see board game AI sample. So if you dive in gameplay ideas, I will pretty soon I will share with you how to play it. So AI, the player has three different modes. One is easy, medium, and best, which is the most difficult mode. And then there are like a mapping out chessboard 8x8. It will AI, pretty much in this game, everything is normal. You can probably do it on your own if you know how to code. But for the AI one, this Unity developer pretty much take this Stanford PhD students, this AI model, pretty much import inside this. So yeah, and then at the end, you can see there is a line and quotes based on the game state. So if you want to take a look, it's the runtime interface. So broad state, the red one is the AI opponent. And the green one is the player. And the star is the place that you can put. And if you put the wrong place, if you see the script, it says illegal state. So if you put the place that is not in the game row, then you won't be able to click and place the chase but instead you will kind of hear the arrow sound. So, and as for this, it will kind of interpret this entire board to this. The empty spot will be 0, and the kind of like the other place, the other kind of like the green spot will be 1. Okay, so maybe I can switch this to here. Oh, give me a sec. Oh, yeah. Okay, cool. Okay, so yeah, my camera just went down. Okay, so interface. So you can see that the empty one is 0 and the player is 1 and the opponent is -1. So this is kind of the interface that once you kind of get in and it will set up this interface. And this one is the means, um, the AI model that being imported through Sentis AI, and then it will show the probabilities for the best place for AI to play to do. So who is likely to win from -1 to 1, and the gameplay feedback. There's also Unity tutorials. If you get the link, feel free to just get in and watch. Okay, so yeah, so I think it's very important to just read the document if you want to learn more. I am learning it, and I love to share with you every week my progress. So yeah, let's dive into the game, and later on we will go back to Onyx. Okay. So, okay, so for those who hasn't played the game, I will show you how this game works. And the way that this game works using AI is the probability of how AI determined how to place the chess that has the highest probability to win. Okay, so let's start playing the game. Okay, so you need to choose the easy one, medium one, or the best one. I usually choose the medium one, and I've been playing for a couple of times, so I believe AI knows my move right now. Okay, so play this. So pretty much you need to try to um, add add something that can uh, mm, here. Um, 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 okay, so pretty much all you need to do is trying to do something like this, and maybe something. Mm, yeah. So pretty much my role is to trying to um, mm, yeah. Um, wow. Okay, so maybe I slowly doing this. Oh wow. Yeah, this is hard. Okay, cool. So maybe this one. So pretty much all you need to do is to, oh, cannot move. So, oh, shit. Wow, this is totally amazing. Ah, okay. So all you need to do, hello, hello, Holman. I'm playing Go game. Yeah, it's very likely. Ah, you will win now. Shoot. Yeah, okay. So I'm playing Go games for this. Okay, so the game play is pretty much you need to kind of like get in between and it will change. Wow, okay, I think AI will be anyway. Okay, so this is the game that we are going to kind of walk through. And this game is pretty much on the Unity, if you want to take a look. I'm still learning, so I just share with you what I've learned. And this is the game, the Sentis sample. So you can pretty much totally um, download the entire GitHub repo, and then you can take a look. So pretty much it used the Stanford students, this person's um, AI model, Alpha Zero, um, to kind of import this model, existing model, and then start training and make this game. So yeah, yeah, if you don't know Sentis AI is a Unity plugin and it's free, and you can use this to import AI model, and then you can run it in your Unity game. Yeah, so there are a lot of I mean, there are some samples, and Unity is unlisted. So pretty much this is still in the experiment mode. So if you want to visualize, because what I find out is that if I click model, this one I've already imported the entire, I import the entire file in. And this one, if you want to serialize this, and the only way to do it is to for example, if you want to open this, yeah, you might need to do always. Okay, so if I double click it, I will see this one. This one is the visualization of this entire game. Yeah, so it creates, I really like this one because this one is from here, Onyx. Onyx, if you wanna think about what's Onyx, it's pretty much a brain of an AI for AI to run. And the most important thing is input and output. So what AI model's way of running is that you give AI model a data, an answer, and then that AI to figure out what's the pattern. So Onyx is pretty much you give it a lot of data, and you give it kind of like I would say an answer, and later on this brain thing will start figure things out. And in the middle, it is there are tons of layers, and the more layers you have, the better training result you will get. Something like that. Yeah. Okay. So let's take a look of this. I'm still learning. If you know anything or have any thoughts, feel free to jump in. Okay. So board in. This means that we are going to create a 8x8 board, and this is more like a kind of like a dimension thing. So so all the AI training using kind of array, which is tensor. Tensor is types of multi-dimensional arrays of data. So if you don't know what's that, then it's fine. Yeah, outputs. You need inputs and outputs, and that AI figure out what's the pattern or what's the formula. Okay, so you create, now we create 8x8 board, right? And then reshape. What's reshape? Reshape means that I want to start from this board to this interface. Okay, so yeah, and then convolution. Yeah, so you import it, you output it, and then we are trying to start trying to shape the entire
Dom,
data.
can you click on
Okay.
the shape again?
Oh,
Click on.
shape. Yeah. If you
Also,
have
can you make your screen
bigger.
like fonts bigger or something?
Oh, okay. Is
Yeah,
this good? Okay, great.
yeah. And then if
Yeah,
you
because
look at, let's
mm,
see, the
yeah, and
shape.
if you want to explain, please, because I'm trying to
Okay.
learn as well. So I believe you know more. Yeah. Okay, go for it.
Well, usually reshapes the tensor.
Mm,
So like the board might be
mm,
um 8x8, I think is the
mm.
number of cells in the board, but
Yes.
I'm not sure what the 1x1 is. It could be like something else, like maybe the color
Yeah, I think maybe
or
the color
and
or
and then
the
maybe yeah.
XY. Yeah.
Well, 8x8 would be enough for XY, but then you also need like the color of
Mm.
placement, and then you have like one more. So
mm,
reshape usually like takes something that's really nested with
mm,
arrays of arrays, and then it will rearrange it
mm.
into like one single array or stuff like that. But it's actually not telling you. So it's just saying the input is some board in and the output is a reshape output. But you don't know the it doesn't look, I can't see if there's any parameters to the reshape, like or it's just four. So
If you really want to see what's going on inside this code, I think there's this Stanford student, PhD student, create a bunch of AI model for training. And this was getting from this person's ONIC or like the AI file. So if you take a look, yeah, he was using more like a 6x6, and he has the entire research paper. So yeah, so I mean,
mhm.
I'm still learning it, so I just share with you what I learned. So in designer, from designer's eyes. So if you wanna, because in Unity you couldn't really open this file because it's not really compatible with this model thing. So you need to download something or install something called Onyx. And this thing is a graph that will help you to see what's going on, right? So it seems like it's easier to understand, even though it's still hard. What's con, right? So convolution operates, consumes input tensor and a filter. So yeah, so Holman, do you have anything you want to explain?
Yeah, well, convolution means it's sort of accumulating
Mm,
the different values
mm,
for a subsection of a input. So if you have like a big image or something, then it will say, well, I'm going to take the average values of all the images in the corner
mm,
first, and then I'm going to walk this sliding window over to the next couple of pixels and then take this image. So that's where I've seen it be used, but I mean, it's just data. So you can use a convolutional network to just sort of um, associate a window of related data, taking the average. So it's just another way of building these connections together.
yeah, so wow, yeah, that sounds very very knowledgeable. I mean, I'm still learning. I'm learning like a Pi TensorFlow. I'm watching the tutorial online and trying to practice. I think the more that I practice, the more that I know that actually this is more like a focusing on input and outputs, and that the kind of like a algorithm to learn what's the right formula. That's what I understand, but
Yeah.
maybe the more that I
So
learned, yeah, go ahead.
you hit the nail on the head, or it's very precise. Is that this whole pipeline here
Hmm.
isn't actually that important. You just
Oh,
need a bunch of them, and then you
hmm,
just give it a bunch of input and then a
hmm,
bunch of samples of correct answers,
hmm,
and then it will go through these layers and tweak them so that the inputs become the outputs. But it's
hmm,
not that important. Like you could put an extra a couple of layers here,
hmm,
or maybe even take out some, and it'll still produce it, but it's about how accurate that data gets and how fast you train the data. So there's some
hmm.
trade-offs there, but you don't really have to go through all of this because like it's not an algorithm for humans to understand. It's just
Oh yeah, I think for somebody who can write this the brain is definitely not human brain. Because I was thinking about I mean I even studied this one. This like a um
it's
yeah
a
any
rectified linear unit.
yeah RALU, I don't know. And what this do is whatever below zero will make it zero. So there's no negative value shows up. So pretty much those three, kind of four or three, will be the layers. And those are trying to, every time it start being trained again, and it will kind of make the value go back to positive because every time when you train it, it will become, some of them will become negative, something like that. Yeah. So this is what I've learned. And yeah, so it will, at the end, this AI model will understand what's the current state of the board and what's the best move. Yeah, so this is the brain. And if you see, because last night I won the game, but I know that the more you train, the more you play this game, the more likely, almost hit to one, like the probability of AI win the game, the closer. So um, yeah, so I feel like the AI becomes smarter and smarter every time when I play it. So this is the AI model. Yeah, if you don't really know it, it's fine because it's not really written for human unless you are kind of like a Stanford PhD student, you kind of know what's going on. Okay, so in this game, pretty much what we did was we have kind of like a main camera, and you can put a game. You put a game level, right? Game level is pretty much the art part. You just set up the environment, and this is the entire code. The entire code is in the Unity repo. You can totally download it. And today I just like go through what I've learned. Yeah, so for this one, so pretty much you kind of attach this somewhere, and you got this code. Okay, so I want to share with you this code. Yeah, so this code, I would say, is probably the most important code that make everything go together. Let me share with you. So this code, you need to import the model that we just talked about. And then iWorker, good code. iWorker is that it abstract the implement between CPU, GPU. I forgot what PU I'm using, but as far as I know, GPU is very fast. CPU is kind of slow, but G, I mean GPU is like a more like a graphic, and CPU is like a use your computer core. I mean, Holman, if you have any explanation of what's iWork, as far as I know, it's just create another parallel uh, updates or world for this AI model to run outside of Unity's runtime. Yeah. Oh, if you wanna
Yeah,
mention,
I'm
yeah.
not that familiar with Unity, but I'm suspect that this is if this is like JavaScript workers, it's kind of like a thread. So you have
Mm,
one program that might be your game loop, and
mm,
this is treated as a separate program. And
mm,
so they kind of talk to each other, but your model is not running. I mean, it's running in parallel with
mm,
your game loop, but it doesn't, they don't, the two don't know about each other. So, and also, yeah, it's using the GPU if it's available, or it could also run on your CPU too.
mm. What's the difference between CPU and GPU?
So they're different pieces of hardware. So your CPU runs um, sort of generic instructions, things like I want you to load memory from here, and I want you to add these things together. And so you can run any kind of software program on your CPU. Your GPU is very strict, and it's designed to spit out pixel colors. So it's all the number of pixels, there's like millions of pixels, right? Because you have thousands by thousands of dimensions. So it's good for running all of these calculations very, very quickly, but it's not really good for general computation. So it's very good for multiplication and summing and all those things that the neural network requires. So we put those things on the neural network. So the GPU can also run different kinds of programs, like the shaders for shading textures and lighting and all that kind of stuff in programs, but it's also very good for mathematical operations that the neural network uses. So you just make that into a program, you put that on the GPU, you execute it, and then you infer it. So you can train on the GPU, But inference is often much cheaper than training it because when you're training it, you go like forward and backward propagation in order to tweak those things. And so that's something the GPU can do like orders of magnitude faster than your CPU. But when you run inference, it's just multiplying through your layers, right? Multiplying in the ReLU and convolution and all that kind of stuff. So it's actually not too bad on your CPU. So you don't have to run inference on your CPU. So like I think the when you install like some of these libraries like PyTorch
Hmm.
and and so forth that they maybe currently are only compatible with the NVIDIA video cards.
Yes. Hmm.
So if you have a different kind of video card, I think maybe you have to you have a harder time finding compatibility. So when
How
you do,
about, because I use my Mac and my Mac Pro is M1 chip. So as for M1 chip, is this compatible for M1 chip?
I don't really know because I haven't tried that on a Mac with M1 chip. I like it has a GPU, so
Mm.
theoretically it could use it, but people have to make drivers for it to load like PyTorch and make it work on it. So theoretically it could, it's capable of it, but it's whether the community has made enough compatible drivers for it to take advantage of that. But I'm saying like when you run this program, like if you don't have the GPU, it's okay to run inference on the CPU too.
Mm.
In your case, I think you're going to use your headset, right? So yeah, yeah, I don't know. Maybe
Mm.
Sentis takes care of that for you. So it maybe already has some software to make it run on the GPU. Definitely, they would want to take advantage of the GPU on your headset. So probably
Yeah,
they would.
I think those like the um AI model, I think Sentis AI kind of trying to um make this AI model run inside Unity environment. Ops means the carry tensor operators. So yeah, so if you
Well,
getting
for
yeah
sure, it runs in the Unity environment, but I'm saying
yeah.
it will try to take advantage of the hardware too,
Hmm.
like the GPU on the uh, on the headset is what I'm thinking.
Yeah, yeah. Okay, so if you see this, you can put it's called illegal move bus. So if you previous saw my so I was playing it. If I click somewhere that is not allowed to put the chess piece, then I will hear this illegal buzzer like a "rrr." So it's kind of like a give you the hint. And this is kind of like the one that telling you that what's going on with the game state. Yeah, so those are kind of the game stuff. And material means that you can put. I remember one is, yeah, so you can put materials red, black. The player is black and the opponent is red. And the other one is transparent. Transparent probably just, all those. Oh, maybe if you see this, I think that there might be something that you can play around. Yeah, so maybe there are some transparent types of chess piece. So yeah, and then flame holder. Yeah, so you can see like all those like pretty much constructed. Okay, so flame fair. So later on, I will share with you again if you forgot, because fanfare means that this is just for AI to understand and show what AI might move. Yeah, so you can see choose character, which means that there are easy mode, hard mode, medium mode, and hard mode. Yeah, so you can choose characters, and those are the directions. Yeah, so you can take a look. Yeah, you can see the difficulties. You can load the tensor, and yeah, those are kind of the data you are loading from the AI model. And then legal moves, right? If you see this like a legal moves, and then yeah, so those are kind of the runtime. I can tell you that I'm still learning it. If you know better, let me know. Yeah. So right now we are running CPU, because GPU not it we don't really know whether my computer is NVIDIA or not. So, and then CPU kind of using for tensor handling. So it will do the next move, and those next move will be the AI prediction, whether this is the legal or illegal one, and yeah, and also if it's kind of like it will also learn whether the AI win or the player wins. So, and
Yeah.
then yeah, go ahead.
This is not actually Go. This is Othello, which
Oh, yeah,
it,
Othello. Yeah.
yeah, you just need to see how many like black pieces or which colored pieces dominate the board. Oh, but
Hmm.
it's not as hard as Go, because Go you actually have to like make a
Kind of,
circle around them. You have to enclose them. But in
yeah.
Othello, you just have to put to the ends of the rows and it
Hmm.
switches up the colors. Right?
Yeah. So yeah. So this is kind of more like a Othello types of game, and this game is called Othello. Yeah. Cool. Okay. So if you see this, you can see like the yeah, so pretty much avatar 1, 2, 3 mode. So if you choose which avatar you select, for example, the easy one, medium one, and hard one, and you will move forward, you can see the difficulty. So temperature means that how hard it is. So yeah, Holman, if you wanna kind of explain it. It's kind of like I don't know, weight or something. It's more like a how closer or how good the probability you want this AI to kind of move and likely to win.
Oh, interesting. Okay, so they picked a number,
Mm,
a floating point
mm.
for, and they assigned it based on the level. So where is this variable used? Can you search where M AI difficulty temperature is used?
Let's see.
That might be the fourth input to the board, I suspect.
Mm,
So copy it and search it.
mm.
So 2 of 5. So keep going, keep going, keep going.
Best move.
Oops, okay, multiple best move. Okay, okay, yeah.
Yeah, one. Mm,
Okay, well, that's the default.
mm,
So go back to that last line that you were
mm,
looking at. Okay, so I think this one.
mm,
So this is the inference, I think, right?
mm.
Is it?
I'm still learning. So yeah, I mean, it's like the best move. According to my understanding, is the one that AI will very likely to win you, something like that.
What is best move? Where's that first defined?
Best move will be. Give me a sec.
Because what's a little confusing is they're still doing like multiplication and division and stuff like that.
Hmm.
Best move, peak output best move as tensor float. Okay. Okay. So they're like grabbing the data from the model
Hmm.
and assigning it here. Oh, okay. So it seems like the best. Okay, so you remember how your neural network had like two outputs that came out?
Hmm. Yeah.
One side was the board state and one side was the best move.
Hmm.
Seems like they have to do a little bit more calculation on the best move because it is also a some kind of tensor. And so based on how difficult you want, it can choose
Hmm.
from the best move. So these are actually your predictions.
Hmm.
So yeah, on line 232,
Hmm.
this is already executing. So this is your inference here.
Hmm.
Is it's doing your number crunching, and
Hmm.
then on line 237,
Hmm.
this tensor contains your best move,
Hmm.
and then down below, if you search
Hmm.
more of the best move stuff,
Hmm.
down, yeah,
Oh,
where
this one.
where best move is used, where they're like
Oh,
multiplying and all that kind of stuff.
this one?
Here, back on line 253,
Hmm.
they're actually um, choosing based on your difficulty temperature. So however
Hmm.
difficult you want to be, it actually simultaneously computes different moves,
Hmm.
and then you take that into consideration. So there's some more operation. It looks like you take your best move, tensor, multiply it by your difficulty, and then take something to an exponent, and then you also add something,
Hmm.
see if it's legal or something, and then you reduce them. So they're making way more calculations and then make readable. Oh, and then it comes out with probabilities, and then you execute it or something. So yeah, they're still doing um, mathematical computations outside of the neural network.
Hmm. So this is something that if you want to download it and you can study it. So this pretty much this code is the entire brain of it. And the rest of it, I remember there are four, right? If you see glow distance, it's just showing the glowing effect. And opponent avatar, it just show like you can put on those three and just show once it being selected, it will move forward. That's it. And this one is the AI model and pieces. You can see, you can see like, oh, when will it being placed? So you can see like those kind of speed, time, and position. Yeah, sprite move, and you can see those are kind of the sprite move. Okay, so I think today is just doing a Othello's one. Maybe we can play again because I feel like yeah, I wanna trying to win the game. Okay, so as for player, we are the so do you want to choose anyone in any game, anyone? Easy, medium, best. I feel like medium is already being trained a lot. Maybe doing easy or best.
Again, I think they're all trained. So
Yeah,
it's just that temperature that it chooses afterwards. So it's the
yeah, let's do
training
easy.
it.
Let's do easy. I feel, yeah, okay. So easy. Hopefully it's not too smart. Okay, so let's do this. Yeah, so you see, oh wow. Okay, cool. Uh,
Oh, so the glow is all possibilities, all legal moves
yeah,
that yeah, that it was considering.
yeah. I was doing this. Yes, so it's more like it's considering something. Oh, I personally think those four plays are very important and the edge.
Yeah,
If you got the edge, you win.
don't let it get to the edge.
Yes, yes, that's what what should I do? Close to the edge is the best or something. Oh, mm, um, yeah, maybe something like this.
And it'll take the edge.
No. Yeah, maybe here. Oh,
Well,
this one
take,
is good.
oh yeah, yeah, get the corner.
Get the corner. Yes. Oh, maybe this one. Yeah. Oh, easy. Easy is good. Yeah. Oh, maybe this one. Oh, um, wow. Um, wow. I think those four corners are great. How can I get those corners? Maybe. Yeah. This is.
Let's just take it.
Yeah. Wow. Oh, wow. This is Wow, I know what she wants this spot. I couldn't do this one. Oh, this is not easy though. Which one?
Yeah, even the easy temperature is pretty hard.
Yes. Yeah. Oh, yeah, this one. I want this one. This one is hard. Wow. Wow. Yeah, so maybe like this. Oh, wow. This one. Oh, AI is so smart. Oh, no. It's dangerous. Oh, wow. Wow. Look at this. Yes, I got this spot. Maybe this one. No. Seems like it's not that smart. Oh, no. Oh, you win. Yeah,
Okay.
this one is not easy. Yeah, definitely. So yeah, so this is the game that we just talk about, and any other questions or any other things you kind of think it's worth mentioning or anything, I will start kind of doing more like how AI and Unity integrate, because people said that, or Orin Barr, the founder of AWE, mentioned last year XR is the um, interface for AI, or spatial computing is the interface for AI. So I think it's great to learn AI. I mean, I am not from computer science background, but I think the more that I practice, the better that I understand. So every week I will share with you my learning process. And yeah, and every week I will be better and better. So yeah, anything you want to mention, Holman?
Mm, not really.
Not really. Okay, thank you so much. And Holman will teach next Thursday, right? And next Saturday, I will share with everyone what I've learned. Maybe it's another one. I'm thinking about doing the other one, which is this one. Um, I will share my learning for sentence samples. If you go down, there's like a depth estimation. So pretty much it will learn AR immersive per pixel depth. So it will visualize distance from the camera, and virtual character is corrected, occluded by physical objects. So something like that, look at this and using this AI training and start creating something more like this distance later on. Yeah, so I will learn it and I will share with you what I've learned. Okay, thank you so much. And I will see you next week. Bye bye.
Yeah.